Okay, so now the sound is coming out on my Facebook. Okay, so the mic is now on for the Facebook. Okay, can any one of you just say something? I just want to see whether it is being detected by the OBS Studio.
Yes, Prof.
All right, line clear. Very good. Thank you very much. All right. Uh, okay, so what's going to happen today? Today, again, I'm going to cover another topic. Okay, as I mentioned before, all these lectures are not coming out in the exam for statistics. They are not coming out in the exam for statistics. So they are going to come out for, what do we say, for the other modules. Okay. So this topic is covered under epidemiology. Am I right? Mantel Haenszel. Has it been covered under EPID?
Co-founder. Come, Prof.
Uh, so did they teach you how to calculate Mantel Haenszel?
Prof. Cuma tunjuk je macam tu, Prof. Dia tak spesifik aja lah. Macam
Okay.
complicated sikit.
Okay. The whole point here, the reason that I'm trying to cover that topic. Okay, because first and foremost, this is one of the more difficult topic, and in the past, it is one of the compulsory question under EPID. So when for one of the essay that's going to come out under EPID exam is how to calculate Mantel Haenszel. Okay, so the reason I'm telling you all this because I want to emphasize on the fact that uh, this one is not going to come out under EPID-STAT. It's not going to come out under statistic, but it's going to come out uh, under epidemiology. Okay, so that is why it's a bit weird. Okay, that's why it's a bit weird. The topic is statistic, but when I'm teaching this, it's going to come out under epidemiology. Okay, all right. So okay, I see the attendance. I already have 29 of you, so means I already got everybody. Okay, so what's going to happen now with this one? I'm going to close your attendance sheet, and now I'm going to transfer my PowerPoint to that screen. Okay, so right now I'm going to change the screen that is coming out on you all from my face to become the lecture itself. Okay, so I'm going to start covering the lecture, which is about Mantel Haenszel. Okay, all right. So right now I'm not sure where it's going to come out. That's the problem. You got three screen. You don't know where the PowerPoint is going to come out. All right. Okay. So okay, yeah. I'm still having problem trying to capture the correct skin. Okay, so I have the mental answer, I got the presenter view, I got the PowerPoint. So PowerPoint I got three. I got PowerPoint show. Okay, that's correct one. Okay, transition. Okay, that's my face. Okay, so I'm going to stop sharing the attendance and I'm going to start showing this. Okay, hide the view. Okay. My apologies for making you all my guinea pigs in this experiment of teaching online. Okay, by right there should be a technician supporting me, controlling everything. But since it is a one-man show, we are doing everything alone here. Okay, in fact, the team consists of I, me, and myself. Okay, so I'm going to spotlight myself. Okay, so right now you should be seeing this in a big screen. Okay, I'm also going to start recording. So the video is now being recorded under Teams. Okay, all right. So we have the recording done. Okay. Again, as I said before, the spotlighted video will not be recorded. So instead, when you come out, it will come out as a screen of 4 pages, a 4-person screen in the recording, and you will see my screen on the top left side under the recording. Okay, so that is one of the things that you have to take note of. That the recording inside Teams will be like this. However, I will try to share the recording that we have on the Facebook inside YouTube, and I will share it with you all. I know the last Thursday one I still have not done. Live has been held the past few days. Okay. There is just not enough one Azmi. We need more than one Azmi to get all the things done. Uh, okay. Okay. So right now we have that. Okay. The other thing I'm going to do is to take the attendance. So I already taken the attendance using the online version of sign in. I'm also going to download the attendance list from the Teams. Okay. Already downloaded. Okay. So now we are going to start the lecture proper. Okay. Okay. As mentioned, I think just now was Farid kot. It was it Farid or was it Zul?
Farid,
Farid.
Prof.
Okay. I wish I can see you in real life later on. Very hard to very hard to thank you, Faiz. Alright, okay. So now we're going to cover Cochrane Mantel Haenszel. Okay. As mentioned by Farid just now, Cochrane Mantel Haenszel is taught under under EPID as a lecture about on how to control for confounders. Okay, on how to control for confounders. Okay, so right now we are going to go and cover this. I know inside the lecture they just mentioned Mantel Haenszel. Okay, but apparently the latest version that we have that is being used in the calculation is really Cochran Mantel Haenszel. Okay, okay. So historically, we have many different kind of statistical tests. Okay, it started with the Pearson's chi-square. Okay, we already covered that under basic stat. Okay, so we have Carl Pearson. So we have Carl Pearson coming up with this test, the chi-square test, way back in 1904. Why did he call it chi-square? As mentioned just now, as mentioned before, because it was based on the chi distribution. Okay, so that's why it is called the chi-square test. And uh, then later on, there was a likelihood ratio test. If I'm mistaken, that is Fisher. Fisher came up with the likelihood ratio test. I did not put his name and the year because I couldn't find the reference for that. Then in 1954, we have the Cochrane test. Then in 1959, we have the Mantel Haenszel test. And in 1980, as a refinement of the Mantel Haenszel test, we have the Breslow the test. And we recently we have the Theron test. Okay, we have the Theron test. Okay, I'm going to cover each one of these. So in fact, when you talk about Mantel Haenszel, it is not one test. Okay, it is a amalgamation of many different tests from the Pearson's chi-square, likelihood ratio, Cochrane test, Mantel Haenszel test, Breslow test, and the Theron test. So I'm going to cover each one of them. All right. Hopefully this thing works. Okay. So why do we talk about the Mantel Haenszel test? As mentioned just now by Farid, when we want to control for confounders, we use the Mantel Haenszel test. When we want to control for confounders, we use the Mantel Haenszel test. Okay, we have the risk factor, we have the dichotomous outcome and the dichotomous risk factor. So we run the analysis. Yay, we say the risk factor is related, is associated with the outcome. But sometimes the association may not be true, but it may be due to other things, maybe due to a third factor. So that's why we can adjust and control for the effect of the third factor. Okay. Okay, I need to change my screen a bit. Why? Because it's affecting my display. It's becoming slow. Okay, my apologies. All right, much better. Okay. Okay, again, I repeat, this one is not coming out in your exam, so don't panic. Relax. Okay. So, for example, okay, we take for example, okay, uh, we talk about coronary heart disease. Okay, we talk about coronary heart disease. We know stress is very much related with heart attack. Okay, stress is very much related with heart attack. So, how do we know who are stressed? People who are stressed tend to have high levels of catecholamine. Okay, catecholamine is the same like indicator for stress, same like cortisol. Okay, if you have a high level of catecholamine, mean you are highly stressed, and when you are highly stressed, you are of higher risk to get coronary heart disease. But as you all know, young people are less likely to get heart disease. Old people are more likely to get one. And those who have no ECG changes are likely to be safe. And those who already had ECG changes, even though they are young, they are more likely to get heart attacks. Okay, so we have two possible outcome here. One sorry. For the outcome, we have the coronary heart disease. We have the coronary heart disease to be present or absent. Yeah, I'm getting messages coming in. I don't know why. Okay, not you all. I'm more worried about you all. If you all are sending messages, means something wrong with the lecture. Okay, so we have then we have the risk factor. As mentioned now, those with low level of catecholamine means they are low, are not stressed. They are happy-go-lucky, always laughing, always enjoying themselves. Those with the high catecholamines are the highly driven person, okay, and they are highly stressed. Again, mentioned just now, there are two possible confounders: the age factor. Here, the age is set at 55. Please take note, this is not the real cut-off point that is useful for you or for me, saying that those who are younger than 55 less lower risk of heart attack. But this is just for the sake of discussion. We say that those who are less than 55 are of lower risk. Those who are higher than 55 is higher risk. Okay. As you all know, I got my heart attack at the age of 51. Uh, about 2 days before my birthday. So does not mean you are below 50, you are safe from heart attack. Okay, ECG, present changes, present or absent. Okay, sorry for the disturbance. All right, next. Okay, if we have the single table, you can see there. Okay, I'm not sure you can see the arrow or not. Okay, ding ding ding. Let's see whether I can get the laser pointer up. Pointer, yay, laser pointer got. Okay. So you can see here, if we have everybody here, the data, there's going to be 609 of them. Okay. Okay, you can see here, out of the 609 cohort that we followed up, in this cohort, there were 71 who developed coronary heart disease, and there were 538 people who do not have coronary heart disease. As you can see, those who are highly stressed, 22.1% of them end up with coronary disease. Those who are not stressed, 9% of them end up developing the coronary heart disease. So don't look at the number. I know you're looking at the doctor. The low catecholamine is 44. High catecholamine is 27. So low catecholamine is higher. But please take note, the low catecholamine people are a lot more. They are 487. So we don't use the absolute numbers. We use the row percent. Again, this table uses the standard EPIC style, where, or maybe not, the word style is wrong. It's use the standard, the convention. Okay, you use the convention where we have the risk factor on the left side, the outcome at the top. The outcome at the top. Okay, so you can see here, when you have the row percent, you can see the those who are highly stressed got higher rate of coronary heart disease compared to those who are low, who have a low stress level. Okay. The message sending me telling me Lazada is on the way. Never mind. Okay. So what were the risk factors? The risk factors were catecholamine. Okay, what were the confounding factors? So the confounding factors here is the age and ECG changes. So what do we do? To control the confounding factors, we will divide the sample into a series of strata, okay, with regard of the confounding factors. So we got the age, we got the ECG changes. So we're going to divide them into the different stratum. So we're going to have 4 extra stratum. And the 4 extra stratum are those who are age less than 55, no ECG changes. This one should be the lowest risk. Those who are age less than 55 with ECG changes, okay, slightly higher risk. This is age 55, no is and above, and no ECG changes. Then this one is age 55 and ECG changes. So this one, this cohort should be of the highest risk. Okay, so the age over 55 and presence of ECG changes should make this group has higher effect on the getting coronary heart disease compared to the catecholamine itself. Okay, so we have 4 stratum. Doctor, how do we know we have the 4 stratum, 8 stratum, 2 stratum? It depends on number of confounding factors that you want to control. Okay, if you have only one confounding factors that you want to control, then it is 2 by the power of 1. 2 by the power of 1 is 2. So you end up with 2 stratum tables. If you have 2 confounding factors that you want to control, it is 2 by the power of 2. 2 by the power of 2 is 4. So you end up with 4 stratum. Okay. If you have 3 confounding factors that you want to control, then it becomes 2 by the power of 3. 2 by the power of 3 is 8. So you end up with 8 stratum tables. Okay. Of course, trying to do for 8 stratum tables is ridiculous. So sometimes you may have to consider other analysis such as multiple logistic regression. Okay. So I hope that's clear. Okay. So let's look at each one of these. Okay. I know there's a slight problem here. I'm going to share the slide with you all. Why there's a slight problem? Because the way I'm placed, I'm covering the value of the odds ratio. Okay. Dr. Azmi here, I'm covering the odds ratio. So what I'm going to do now, I'm going to hide myself. I'm going to hide myself so that you can see the odds ratio. Okay. Let's try and see whether I can hide myself. Dang, 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 dang. Ding. All right. Still cannot see the odds ratio. Okay. So down there at the bottom, okay, down there at the bottom, you see the odds ratio. So the odds ratio is AD over BC. AD over BC. So you have the odds ratio A1, D257, B7, C17. Okay. So AD over BC. So you end up with 2.16. So please take note the odds ratio here. It is 2.16. The next one, the odds ratio is 1.59. Okay. So you can see here, this is the highest group. So the highest odds ratio is 2.16. Indicate that if you are young and no ECG changes, then the chances of you developing coronary heart disease due to stress is the highest. Okay, it is the highest. All right. Okay, Sumi, don't worry about the QR code. We will settle the QR code later. Okay, so okay. Okay. So you see it is 2.16. Okay. So 2.16. Next, we have the second group, which is 1.59. So means now the contribution of stress is less compared to the ECG changes. So ECG changes contributes more towards the risk of getting coronary heart disease. If you are old, and no EC changes. The odds ratio is 2.14. So the contribution of catecholamine is still quite high. Here, with for the elderly age above 55 and presence of EC changes, you can see the odds ratio is much lower at 1.72. So this is the lowest. Okay. So therefore, what it's telling you here, stress is less of a contribution for coronary heart disease compared to the EC changes and the age factor. Alright, so that is the story about this. Okay, so let's summarize. Yeah, let's summarize. Okay, so you can see here. So you can see here. Okay, right now I'm floating on nothing. Ah, okay, I think I can do this without the background scroll. Okay, cannot. Alright. Okay, so what's happening here? What's happening here? Yeah, the green color, something wrong. Oh, I see. Very sorry. I just realized that the sun is falling on everything differently today. Okay. So you can see here as the odds ratio progresses down there. Okay. ECG changes uh, less than 55, 1.59. H quite high. ECG changes 1.72. Elderly, no ECG changes 2.14. Young, no ECG changes 2.16. Okay, so you can see the progress as mentioned just now. But weirdly, the combined table is high, 2.86. So right now, you know that there is a confounding issue. You know that there is a confounding issue. Something wrong with the odds ratio. Why something wrong with the odds ratio? Because the value of the odds ratio for the combined is higher than the respective stratums for each one of the smaller group. Somehow the combination make it become higher. Okay. So, okay, what is wrong here? So you have to adjust. You have to adjust. All right. Okay. So how to calculate for the odds ratio? We also have to calculate the odds and the CI. We have to calculate for the CI, confidence interval. Okay. I need to excuse myself for 2 minutes. I need to go to the bathroom. Yep. 2 minutes. Yep. Very sorry about that. Orang tua, elderly people. My apologies. Okay, so you can see here the problem now. Okay, so to see the problem, you have to look at the odds ratio. And when you look at the odds ratio, when you look at the CI, we have a problem. What's the problem? All the values were not significant. Okay, all the values were not significant. Do you know why it's not significant? Zul, I said that these values are all not significant. 1.59 not significant, 1.72 not significant, 2.14 not significant, 2.16 not significant. Why? Hi Zul. So when I say the value of the odds ratio for the each of stratum, all the four stratum are not significant. Why am I saying it is not significant?
The confidence interval shouldn't cross 1.
Yes, thank you very much, Pepe. Zul belum makan kopi, minum kopi lagi.
Okay, Prof.
Okay, thank you, Pepe. So as you can see here, it did not. It already crossed the value of one. The minute the value of one means odds ratio no significant difference. So any of this value crosses the value of one, then it is no longer significant. This one look fantastic. Wow, 18.58, so big, but it is not significant because it crossed the value of one. If you look at the combined one, it is significant. It did not cross the value of one. It is between 1.69 to 4.85. Okay. So under advanced stat, we expect you all to be able to calculate it manually. Okay. Under the basic stat, under basic APIT, as a student, I had to calculate this manually. Okay. So for you all, I'm not sure. Okay, it is very much dependent on the lecturer. Okay. If the lecturer understands this very well and wants to test you, he or she will set this as a question. Okay. But for me, I will reserve it for the advanced stat. Okay. So what is the important thing here? What is important here? Despite stratification, uh, it does state that you end up with higher odds, but it is not significant. There seems to be little effect motivation due to age and ECG. The odds are similar, but surprisingly, the combined table is stronger and highly significant. Okay, so we know already the combined odds ratio something wrong. How can you have a combined odds ratio bigger than the stratum's odds ratio? So we need to come up with a corrected, or what the term we use here, adjusted odds ratio. Okay, and we need to adjust for the effect of age and ECG changes. Okay, okay. This is the formula for the chi-square Cochran Mantel Haenszel. Okay, as mentioned in the history just now, we have Cochrane came up with this formula first, then Mantel Haenszel refined it further, and they call it now the Cochran Mantel Haenszel formula. Why not Mantel Haenszel itself? Because if you check, when we show you later, you will see that Mantel Haenszel got a different analysis. So the Cochran Mantel Haenszel, okay. Doctor, so complicated, how to memorize? AD over BC, remember? AD over BC. So now instead of AD over BC, you have AD minus BC. AD over BC become AD minus BC. Divide by n squared. Here again, for the bottom formula, it is the sum. It is the sum, all the outside table. A plus B, C plus D, A plus C, B plus D. These are all the subtotal outside of the four squares. Okay, that are on the above part, and then you have n minus 1 times n squared. Okay, this one you have to remember, you have to memorize. Okay, the above one quite easy because instead of AD over BC, you have AD minus BC divided by n squared. So that is the formula. Okay, so let's start to calculate the chi-square Cochran Mantel Haenszel for this data. Okay, so as mentioned just now, we have the exposure on the left side, we have the disease at the top. Okay, I emphasize on that. I emphasize on that. Always come at the top, exposure on the left side. I need to make myself go missing sekejap. Why? Because I'm covering the formula. Alright. Okay, so you can see the formula now. Okay, so let's go to the next one. Okay. Okay, so you can see here. Okay. Again, the formula is being affected by all this mambo jumbo. I'm going to switch off the background. Okay. So much better now. Okay, you can see everything. Okay, so you can see here. So based on the formula, you have to put in everything inside there. Okay, so you see the first one. Okay, this one came from the table A, the first stratum. Sorry, the first table, not table A. So the first table. Okay, then you have the second table. Then you have the third table, and then you have the fourth table. Okay, so these are all the tables, the four stratum that you have. So you end up with four calculation. 1, 2, 3, 4. Okay, so this 1, 2, 3, 4 came from the four stratum tables, and that is how you calculate the chi-square for Mantel Haenszel. Okay, so let's go next. So this one shows you how we calculate and give you the total. So you can see the total for the chi-square Mantel Haenszel is 4.15. And as you all know, okay, for 4.15, the level of significance is 3.84. So it is significant. Okay, since the level of cutoff point is 3.84 for p equals to 0.05, therefore the value is significant. Okay, so interpretation. After adjusting for age and ECG, you can find a significant relationship. There is a significant association between catecholamine levels and the chances of developing coronary heart disease. Okay, after adjusting for age and ECG simultaneously. So please take note, and for the chi-square Mantel Haenszel, the chi-square is for 1 degree of freedom. Okay, why? Row minus 1 times column minus 1. So 2 minus 1 is 1. 2 minus 1 is 1. So 1 times 1 is 1. Degree of freedom is 1. Okay, so that one is for the chi-square Mantel Haenszel. As mentioned just now, not only you have to do the I just realized I'm giving a lecture, show you all the gesture and movement, but my video is off. Alright, sorry. Okay. So for the chi-square Mantel Haenszel, okay, as mentioned just now, we have the odds ratio, and the odds ratio for the stratum is quite low. But now, when we do the combined one, the combined odds ratio was surprisingly high. Therefore, there is something wrong with the combined odds ratio. We need to adjust. So how do we adjust? We use the Mantel Haenszel adjusted odds ratio. So please take note. So first we have the Cochran Mantel Haenszel chi-square. For the odds ratio, it's just Mantel Haenszel adjusted odds ratio. Okay, so Mantel Haenszel adjusted odds ratio. Okay, so you can see here. Tak boleh. Okay. So now we need to calculate the estimated adjusted odds ratio. So we need to calculate the estimated odds ratio. So you can see here, okay, we need to do the necessary calculation. Again, as mentioned just now, the formula is like this. Because the formula is like this, we have to adjust. We have to adjust. We have to prepare the table. And the table, as mentioned just now, looks like this. Okay, the table looks like this. Okay, so now we have to put in the values, and the values look like this. Okay, so we have table 1, table 2, table 3, table 4. So once you include the values for table 1, table 2, table 3, and table 4, you can calculate the adjusted odds ratio. Okay, so we got the value of the adjusted odds ratio was 1.89. As mentioned earlier, you can also calculate the confidence interval. So confidence interval, this is the formula 1 plus minus z1. So this one is the z for 1.96 divided by the chi-square Mantel Haenszel. So the chi-square Mantel Haenszel, the square root of the chi-square Mantel Haenszel. So the square root is the chi-square Mantel Haenszel was 4.15. So the square root of 4.15 is 2.04. So 2.04 times 1.96, you end up with 0.962. So 1.9 plus minus 0.962. So you get the values like this. So it is 1.89, 0.038 until 1.9, 1 by the power of, so not power, exponent, 1.89 exponent 1.962. So you end up with a value of 1.02 and 3.49 for the confidence interval. So you have the value of 1.9 and the CI is between 1.02 and 3.49. It does not cross the value of 1. Therefore, after adjusting for the odds ratio, it is still significant. It is still significant. Okay. My apologies for the screen. Okay. I know my scrolling text is affecting it. My big body is blocking the view. I cannot change already. The camera keep following me. Okay, this is bad, I think. Okay, there is a significant relationship between level of catecholamine and coronary disease. After adjusting simultaneously for age and ECG, the p-value is significant, less than 0.05. The adjusted odds ratio is 1.89. Okay, please take note, adjusted odds ratio is 1.89, not the other value, which was 2.86. Okay, so the adjusted odds ratio is 1.89, where the CI is between 1.02 and 3.49. And since the CI does not include the value of 1, it is significant. As mentioned by Pepe, if it includes the value of 1, it is not significant. If it does not include the value of 1, it is significant. Okay? All right. So those who are stressed have a significantly higher, okay? Remember, it is 1.89. So 1.89, you cannot go down. You go down, you end up with 1. So you have to go up. So 1.9, you go up, it becomes 2. So those who are stressed have a significantly higher 2 times risk of developing coronary heart disease compared to those who are not stressed after simultaneously adjusting for age and ECG changes. Okay, so that is how we do the Cochran Mantel Haenszel for both the chi-square and the odds ratio. Okay. He. Okay. Okay. On this Friday, the message was about the Syarahan Perdana this Friday for Professor S. Fadilah. I'm the technical guy. I'm the guy in charge of the broadcasting. Uh, so you can check out the posters and attend the register to attend the Zoom session. Okay. Okay. So let's not worry about that. Okay. Okay. All right. For those interested in attending the Syarahan Perdana, the URL is tinyurl.com/Syarahan Perdana. Okay. So let's go next one. By the way, for the word Syarahan Perdana, is the S is capital, the P is also capital. So Syarahan Perdana. Okay. So let's go next one. Okay. Are we done yet? Nope. Remember we said there is Breslau D test and there is the Tyron test. Okay. So what's the point with the Bres? Okay, we already got the basic. Okay. Okay. So after you got the adjusted ratio, after you got the Cochran Mantel Haenszel, that one just say whether there is any association between the risk factor and the outcome after controlling for the confounders. Okay. But you have to see the other part. Okay. The other part is about the independence. Whether the confounder is related to the risk factor. Whether the confounder is related to the risk factor. For that, we have the Breslau-Day test. Okay. So, Breslau and Day provided a test for assessing the homogeneity of the odds ratio across many tables and stratum. Okay. Breslau-Day test provide a test for assessing the homogeneity of the odds ratio across many tables and stratum. The derivation include a quadratic equation. Okay, therefore usually we don't calculate this manually. Instead, we use the SPSS. For me, I use Excel. Why? Because I'm good with Excel. So I use Excel to bypass the need for quadratic equation. But today I will show you how to do the quadratic equation also. Okay. Remember at the start of the slide, I mentioned that this thing was quite recent, 1969. Okay, let's go back to the first slide. Okay, let's go back. Let's preach home. Home. Okay, nak work. Home. Tak boleh jalan. Okay. Okay, don't worry. Okay. Why don't worry? Because I got access to the PowerPoint itself. Okay. So we talked about the Breslau test. It was in 1980. Sorry, not in the 1965. It was in 1980. So what happened in 1980? In France, in Paris, they have a meeting on how to calculate the risk for developing certain type of cancers. So Prof. Breslau and Prof. Day was there, And when they sit there, they came out with a new method, and they call it the Breslow-Day test. Okay, and this is the formula. This is please take note. You can Google for this the original publication on the internet. That's what I like about the internet. Knowledge is there. Knowledge is there. You just have to switch on your computer, click in the thing that you wanted to know, and you can get the original publication. I have the original publication. It's damn thick, man. It's damn thick. It's about the proceedings of the cancer symposium. And inside there, in one of the chapters, is about the Breslow-Day test. And this is the formula. Yes, this one is really Greek. This is not the Greek like the Stadium Fifira Mika. This is real Greek. Okay, this is real Greek. Not like the Stadium Fifira Mika in Padang Terap. Okay, so you can see here, this does not make sense whatsoever. This one, you enter into Google Translate, you cannot get the answer. Okay, the Stadium Fifira Mika, you can enter inside the Google Translate, and you can see that it does not mean anything. Fira, yes, Fira means pretty. Mika is the name of one of the prophets. I think so. Okay. Then okay. So what I wrote down there, the words does not make any sense at all. Okay, so instead the best way to show it by showing you the calculation. Okay. Doctor, this is even worse. We cannot even understand anything. Yeah. Okay. So basically they need to come up with what we call a standardized value. If there is no difference between risk factor and the outcome, what is the odds ratio supposed to be? Yeah, what is the odds ratio supposed to be? Sorry. If there is no difference of risk between all the stratum, okay, what is the odds ratio supposed to be? The standardized odds ratio. So this one, the Breslow-Day test will do this by first calculating the expected odds ratio table if there is no difference of the effect of the different stratum. Okay. 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 So again, please say, so here you are supposed to calculate the odds ratio first. We have done this earlier, and we know the odds ratio is 1.89. Doctor, why are you using the same data set? I am using the same data set so that the explanation makes sense. If you download the original notes, uses a data set about cancer from NICE, N-I-C-E. I don't know how you pronounce the place in France. NICE ke Nice? Nice N-I-C-E. Okay? As you all know, the adjusted odds ratio for all is 1.89. So right now, we need to calculate the new stratum to get odds ratio of 1.89. What is the expected value for cell A? What is the expected value for cell A? Okay, doctor, how come this one cannot be seen? Because this one is in green. So as you all know, I use green screen. So end up this thing become black. So the value is 0.8943. What was the original value? The original value was this, 1. Okay, how do we get this? Okay, so this is the formula. Okay, so 1.9 is equals to AD over BC. Therefore, okay, it should be like this. A times D, B, C. As you all know, AD and BC is affected by the value of A if the sum for the outside is fixed. Okay, so the value of A become, okay, I think I'm blocking it. Okay, the value of A is 0.8943. Okay, I think the next slide is the slide showing how to do the quadratic equation. Okay, okay, I'm going to make myself go missing. Okay, all right. So how I make myself go missing? Ting. Okay, so now you can see everything. Okay, for the quadratic equation, since you know already, the odds ratio is 1.89. You know the value is A, it's like that. You know the value of B is 8 minus A. You know the value of C is 18 minus A. You know the value of D is 274 minus 18 plus A. Doctor, where are you getting all this? From this table, the first item. So you got this one, okay? So to get the value of B, you got, this is B. Sorry, this is B. A, B, C, D. Okay? So this B is 8 minus A, you get this value. To get this value, okay, it is 18 minus A, you get this value. To get this value, okay, okay, so it is 274 minus 18, okay, plus A. Then you get this value. Okay, so this one is 18 plus A. Yes, 18 minus A. 18 minus A. So 18 minus A. So this one 274 minus 18 in bracket minus A. So they end up become 274 minus 18 plus A. Alright, so for this value. Okay, so this is the explanation. Sorry, I'm using the arrow in the wrong place. Okay, so this is the explanation. Okay, next. Who showed me how to calculate quadratic equation? It was Ehsan Zamzuri. Okay. So based on that, this is the best part. You have to do the quadratic equation. To do the quadratic equation, you put in all these values, you end up with this final value. So you end up with a value of 0.89a squared minus 0305.14a plus 272.16. And this you have to enter into the calculator. Okay? And this is how you have to enter the calculator. So you have to take out your calculator, this calculator. Okay. First you switch on your calculator. Okay. Then you press mode 3 times. 1, 2, 3. Okay. Okay. So you get equation. You select EQN for equation, which is number 5. Okay. Then you select. They give you this kind of table. Sorry, I forgot. My camera is not on. Okay. You get a list of all these equation. You will look for the equation. So for me, the value for A is 0.89. I press enter. Then I put minus 0. Yeah.
We cannot see which screen are you referring.
Don't worry. The best part, I have this on video already. Okay, so I will share with you the video on YouTube on how to do this on your calculator. Okay. No, I always prepare ahead. I know already that you all cannot follow one. So we already had this thing on on YouTube. Okay, and we finally 272.16, okay, equals, okay. So what happened now? When you click OK, you get the answer for x1 and x2, okay, and you get the answer here is for x1. Okay, I'm going to stop the scrolling text because it's affecting your ability to see. Oops. Okay, so you will get the answer for x1 is 3, x1 equals to 341.959, x2 is 0.894. Okay, so based on that value, because you get 0.89, you know already, the 0.9 makes sense, the 341 does not make sense. Why? Because your sample size is 282. Since your sample size is only 382, there's no way the x value to become 341. So you take the value of the other angle, which is 0.89, and which is giving you the value of A is 0.8943. Okay, this is how we do quadratic calculation inside your calculator. Okay, doctor, are we expected to know this? Nowadays, because of SPSS, nobody knows how to calculate manually. Okay, nobody knows how to calculate manually. Only those who come to my class know how to calculate manually. Okay, is it useful? It is useful for understanding from which sky all this value come from. Okay, otherwise you just take everything like gold standard coming from SPSS. If SPSS makes a mistake, you also make a mistake. So that's the nice thing about knowing how to calculate this manually, because you can check the answer from SPSS. You can check the answer from SPSS. Okay, so that is how we know the value for A for the first stratum is 0.89. Okay, so we have to get for each stratum, okay, the null hypothesis variance of the cell count, and each one of them must be 1.89. You must fix the oscillation to become 1.89. So now after that, you can see that for the variance for this value, okay, okay, you have the A, B, C, D. A, B, C, D. So you end up getting the numbers to put at the below to get the variance for each table. So you end up with the variance of each table. Okay. To make life easier for you, I already have the Excel spreadsheet for you all to download from my website. Okay, for you to do all this calculation automatically. Okay. So you can see here now, okay, we have the observed value. This is the observed value. This is the expected value. Okay, so now you have to get the difference. So the difference is 1 is for the observed value, 0.89 is the expected value, so you have to get the difference. Divide by what? Divide by the variance. This one is the variance. Where it come from? From the table earlier. This one. Okay? The variance of all the statement. So this one you have to do many times. You got 4 tables, you have to do it 4 times. Okay? And it looks like this. Doctor cannot see, the color is horrible. Yeah, that's my mistake for choosing the green color to highlight that value. So what happened when I choose the green color mix up with my green screen, you end up with this horrible transition. Okay, okay, I don't know how to do this lah. By right, it should not affect because the green screen is only for my video. So I do not know why the green screen is having an effect on this. Okay, let's see whether I can remove it. Can remove. Okay. Okay, much better. But now filters for my see what. Okay, now much better. So the green screen was wrongly put on the Windows capture. Okay, so now you can see clearly now all the values in yellow. Okay, and this is how we get the Breslow day square. The Breslow day chi-square. The value is 0.164. Okay, so you can see here the concept is like this. Okay, I'm going to show you the concept. Okay, you have this original odds ratio 2.16, 1.59, 2.14, 1.72. You know already the adjusted odds ratio for overall is 1.9. So you need to fix the stratum for the expected value. Each one of them is 1.9. So this one 1.89, this one 1.9, this one 1.9, this one 1.9. For this to become 1.89, therefore this value must change. The cell here must change. So from 1, they become 0.8. When they become 0.8, you get the value of 1.89. From 3 become 3.30. This one become 1.89. From 9 become 8.442. This one become 1.89. This one from 14 become 14.284. This one become 1.89. So based on the odds ratio, okay, you can calculate the A. This is the A. This is the A. This is the A. This is the A. And this is the variance of each stratum. So the variance of each stratum, like this. This one, divide by this, you get this value. Okay. This one, okay, divide by this, you get this value. Okay. Sorry, the other way. Haha, the other way. This one divide by this. Okay, so you end up with the Breslow day square. Okay. All right. Okay. So you have the Breslow day, which is the A minus A divided by the variance. So A kecil is observed value. A besar is the expected value. So what happened now from here to get this value is this one minus this one divided by this one, you get this. I repeat, this one minus this one, this one, okay. This one minus this one, divide with this, you end up with this value. This one minus this one, divide by this, you get this value. Okay. So this one, okay, 9 minus 8.442 divided by 4.447, you get 0.07. And here is A is 14 minus 14.284 divided by 2.9276, you end up with 0.0275. So and you combine all the value for each stratum, the Breslow for each stratum, you end up with the Breslow day chi-square, which is 0.164. And I hope that's clear. Okay, so you get end up with sum. Okay, so now what you do? You look at the chi-square table. You look at the chi-square table. How many is the degree of freedom? You got 4 stratum tables. So you got 4 stratum tables. Okay, since you got 4 stratum tables, the degree of freedom is 3. The degree of freedom is 3. Since the degree of freedom is 3, you refer back to the chi-square table. You look for the table A3 chi-square table. You look at the degree of freedom of 3, the value is 0.164. As you all know, degree of freedom 2, it is already 5.99. So 0.164, of course, is not going to be significant. So you can see here, 0.164 is where? 0.164 is smaller than the 2.37 value. So the p-value is larger than 0.5. So here is 0.5. The p-value is larger than 0.5. Okay. So the chi-square for Breslow day test is not significant. P is larger than 0.5. But what is important? Okay. What is important is the what to conclude. Okay. Since the test of homogeneity is not significant, the odds ratio for all is 1.89. So this value and the 1.89 is not different. This value and the 1.89 is not different. This value and the 1.89 is not different. This value and this 1.89 is not different. That is what is meant by homogeneous. So the odds ratio for each oscillator is similar with the standardized odds ratio. Sorry, with the adjusted odds ratio. Okay, so therefore, all the odds ratio of the stratoms are homogeneous. Okay, Doktor, SPSS boleh buat? Can. SPSS will do it in a blink of an eye. Very fast. One click of button, result come out automatic. They give you the value of 0.164. And Theron was also calculated to be similar at 0.164. Who is Theron? Theron is the person who further refined the Breslow day test. And this is Theron's correction. So Theron say, you should subtract Theron correction from the Breslow day test to get better chi-square approximation. Okay. This is really, really Greek. More Greek than the Stadium Fifiramika. Okay. So you can see all these Greek words. Ini really, really Greek. Okay. If you think just now the Breslow day test was bad, this is even worse. So now the correction is much more complicated and the variance calculation is even more worse. Okay. You want to calculate manually? Okay. So Theron says by using the MH odds ratio estimator instead of better conditional maximum likelihood estimator, the Breslow day test has become like the conditional likelihood score test. Since the Mantel Haenszel estimator is inefficient, Theron noted that the test statistic is stochastically larger than a chi-square random variable under the homogeneity hypothesis. So he wrote in 1985, this paper derived the appropriate modification of the heterogeneity score test when the parameter of interest is estimated by an inefficient but consistent estimator. Okay. Okay. Luckily for you all, I did not have the time to calculate the Theron adjustment. In a way, it is not really required, because as you can see, the value for the branch load test and the value for the terrace adjustment is the same. Okay, the value after the Terron correction is the same. Okay, so so in summary, Cochran Mantel Haenszel test, assume common ratio and test if it is equivalent to 1. The Mantel Haenszel estimate or the ratio averages the numerators and denominators before taking the ratio. Then the Bachelor day test, check if the odds ratio are indeed common using discrepancies between the observed and expected. Okay, so as I explained just now, we have shown that the odds ratio for each stratum is not much different than the standardized odds ratio, the adjusted odds ratio. Okay, Tyron's adjustment claims that using MH odds ratio is uh, is an okay. Tyron adjustment claims that using MH odds ratio estimator for the test of humidity is inefficient. Okay, so the MH odds ratio estimator uh, is inefficient, therefore needs to be corrected. Okay, so I couldn't figure it out despite all this time I have under the PKP. Maybe once I retire, I can have a look at it again. Okay, then we can come up with another part of the lecture. Okay, so what is the estimator? Okay, you look here under Breslow day test. Okay, they come out with the Mantel Haenszel estimator for the odds ratio. So he said it is inefficient. Okay, therefore he wants us to do a correction. Okay, so instead of having the quadratic equation, they have a new kind of calculation for the Tyron correction. So therefore, until I can figure out, I give up. Okay, how did I figure all this thing out? For the Breslow day test, I had Anandan, one of my student, SSKM student, to do a project for 1 semester to find out about Breslow day test. He found the original publication, but he cannot convert my data to be used for Breslow day test. Instead, he used the original data from the nice cohort, which was published inside the Breslow day paper. Okay, so what I did was I reread the book, the publication, and managed to figure out how he calculated the Breslow day test. I did not know how to do quadratic equations, so I used Excel spreadsheet to cheat using minute adjustment of the whole thing to calculate the Breslow day test. Ehsan last year showed me how to do the quadratic equation. So once I figure out how to do the quadratic equation on the calculator, I managed to calculate this Breslow day test using the quadratic equation. And I've uploaded the video on my YouTube. You can have a look. Later I will share the link. Okay. Terron adjustment, I have yet to do it. Yeah, Terron adjustment, I have to do it. But 2 years ago, I decided to check the analysis. I calculated everything manually, and I compared the answers with SPSS. All this while, we thought SPSS is the gold standard. SPSS is the gold standard. There's no mistake there. So I use the same data set and I ran the SPSS on the same data set. Okay, so you are going to be surprised. Okay, as you can see, this is the data set. You can download it. The best part after I did this data set, I managed to download the original data set, the raw data set. And it is available on my website. Okay, you can go and have a look at my website, drtamer.me. You can go and download data and run the analysis. I think you'll be very happy to be able to do this. All right, doctor, cannot see the link. Okay, okay, you can see the link here. I'm going to switch off the background scroll. Okay, so that's the link down there. Write it down. Okay, you can using that link, you get the complete data set and also the notes for this lecture. Okay, I believe in sharing the knowledge. Okay, although it took me years to come up with these notes, I have no problem of sharing these notes because I do believe knowledge like this should be shared. Other people shouldn't have to suffer the way I suffered to learn about this. Okay, so we ran the analysis. This one what we did was we did the shortcut by using frequency weightage. So don't worry about that. You can download the original data set from my website. Okay, so you run the analysis. You can see there what button to click. So basically you're clicking on race to get the odds ratio. So you get the odds ratio here for each one of the combined table. So this is the combined table. Then we run again. Next step, which is to do the Mantel Haenszel. To do the Mantel Haenszel, you have to do the second layer. So you have the first layer. So this is the first layer. Then after that, you do the second layer. So the first layer you have is for the age. The second layer is for the ECG. Okay. So when you run the test, you click Cochran Mantel Haenszel. Okay, and you will get this table like this. And the expresses the new one, it looks like this. So you have 4 tables here. What are the 4 tables? This is the first table, second table, third table, fourth table. So there are 4 stratum here. So these are the 4, which is 2.86. Although the CI is significant, 1.688 and 4.851. So this one does not make sense because the value is larger than all the 4 stratum. By right, it should be somewhere in between. As you can see, 1.89 is somewhere between this and this. Okay, so you follow next. Okay, so the odds ratio is stated here. So the odds ratio for the combined table is stronger and highly significant. So it means the result is there is something wrong somewhere. So you need to adjust for the effect of age and ECG. Okay. So as mentioned now, is it homogeneous or not? You can see that age and ECG changes. There's no interaction between ECG changes with the catecholamine level. So, and the test of homogeneity is not significant. All the also show the stratums are homogeneous. Okay, the changing level of age and ECG did not change the coronary heart disease odds ratio so much. So we already explained this now. So there is no difference between the stratums OR and the standardized OR. Okay. The adjusted OR is 1.891. The p-value is significant, indicating the OR is significant. Okay, 1.891 p-value is significant. The p-value is based on the CI, because the CI does not include the value of 1. So therefore it is significant. So 0.044 means it is significant. Okay, so 1.891, it is significant. Why? You can see already, okay, it is the selang keyakinan, okay, the odds ratio 1.017 and 3.516 does not include the value of 1, the CI. Okay. The next thing is age and ECG a confounding factor for this test. Okay. Okay. So if we consider it to be a confounding, if it is larger than 10%. Okay, if it is larger than 10%. The problem now, you want to say 10% based on what? Okay, there are two formulas. For EPID, okay, if you check the notes for EPID, 2.86 minus 1.891, that one understood lah. Because 2.86 is uh, the crude one. 1.891 is the adjusted one. So crude minus adjusted. For the adjusted, okay, so for the denominator, for EPID they take the 1.891, which is the adjusted OR. For stats, they take the 2.86, which is the crude OR. So it could be 50. The difference could be 50. The magnitude of confounding could be 51%. It could also be 33%, 34%. Okay. So it could be. So what? It could be either 51 or it could be 34. Anyway, both are larger than 10%. Therefore, age and its changes are positive confounding factors for the catecholamine. They are positive confounding factors for the catecholamine. Okay. So, doctor, which one to use, EPID or stats? I have done the most research for this lecture for this topic. Of all my other things, I did not read so much. I did not study so much. This is the one that requires the most work. So both are correct. Because one is under EPID approach, the other one is under stats approach. So it is not for me to decide which one is right, which one is wrong. Okay. So both are correct. Which one I prefer? Divide by the adjusted. Divide by the adjusted. Because adjusted is the correct one. Because adjusted is the correct one. Why should you divide by the incorrect one? Okay. You should divide by the correct one. Okay. I would like you all to look at this carefully. The formula we did, the manual calculation, the Cochran Mantel Haenszel, we got 4.19. And our odds ratio was 0.041. So in fact, under SPSS, if you're talking about the Mantel Haenszel, you're not supposed to take this one. You're supposed to take the top one. The top one is the correct answer, which is 4.19. So please take note, you want to do Mantel Haenszel. If you are using SPSS, you don't take the Mantel Haenszel value. You take the Cochran's value. Okay. Mantel Haenszel here under SPSS is the wrong formula. Okay. Why? Because this formula is not for the Cochran Mantel Haenszel. This one is for the adjusted Cochran's Mantel Haenszel. Okay. If I'm not mistaken, the next one is I show you how I calculated the adjusted one. Okay. So you can see here, this one shows you the Cochran's Mantel Haenszel 4.15, 4.19. The p-value is 0.041. So that is correct. But for the adjusted one, okay, so this one is all correct. My slide share, my SPSS, my Excel also got 4.19 same. Okay, the answer is same, 4.15 for the p-value is 0.042. Okay, same, no problem. So the real one, the Mantel Haenszel, given inside SPSS, is really the continuity corrected. Doctor, what is continuity corrected? The continuity corrected is used only if one of the cell got the value of 0. Wah, so shocking. Why so shocking? Doktor, tadi ajar tak sebut pun pasal kosong. AD over BC cannot be calculated if your odds ratio has got the value of 0. If AD over BC, one of the value got 0, A times, let's say D is 0. A times D 0, you get 0. So automatically you can get the odds ratio. You get 0. So continuity correction, chi-square Mantel Haenszel, is used only when one of the cell has got a value of 0. Okay? So continuity correction, chi-square Mantel Haenszel is okay. You're going to have a lecture soon on clinical trial. They're going to show an example of a study which cannot be calculated because the control group is so good, nobody died from the control group. Okay, so the outcome was 0, so they cannot calculate the odds ratio, which is really a lot of BS. Why? Because if there is a value of 0, you don't use the normal odds ratio, you use the adjusted odds ratio. You use the continuity corrected chi-square Mantel Haenszel to do all the calculation, and you do the continuity corrected odds ratio uh, odds ratio for that. Okay, so that's why it is different. So the continuity correction is only for when one of the cell has got the value of 0. One of the observed data got the value of 0. Okay. So any of cell count in any of Stratum stable is 0, then continuity correction should be applied. So this is the continuity correction. So how they avoid getting the value of 0? By adding the value of minus 0.5. So there is no more 0. Okay, I hope that's clear. Okay, so this is continuity. So that is why SPSS salah. The SPSS is wrong. So Cochran's Mantel Haenszel, in fact, is the top line. The second line, which they put Mantel Haenszel, is really continuity corrected. I know it was shocking news for me too. Because 2 years ago when I saw that, wow, and the students were very unhappy because only the answer kunci jawapan berbeza. The answer key is different. Okay, I hope that's clear. And please take note, there are many other Mantel Haenszel tests. There are many other mental. The Mantel Haenszel test that you see inside AP info is a different mental Haenszel test. Is I give you the formula. Doctor, why so many explanation? Because everybody is confused. Everybody is arguing, oh, I got the correct mental answer. I got the correct mental answer. Okay, so this is the explanation about all the different mental Haenszel tests. Okay, and this is how the whole thing is calculated at the end of the day. All right, so I hope that's clear. I hope that's clear. Of course, the best part was about this thing. I found the original paper discussing about all this formula, and it was a very good read, and I finally understood where all these values were coming from. Okay, all right. So conclusion, as before, there's significant relationship between catecholamine and coronary heart disease after adjusting simultaneously for age and ECG. The adjusted OR is 1.89, and it is significant. And those who are stressed have those who are stressed have 2 times higher risk of developing coronary heart disease compared to those who are not stressed after simultaneously adjusting for age and ECG changes. Okay, so these are all the references. As you can see, I did look up the Robert E. Theron original publication. Yeah, it was published on Biometrica. Surprise! Okay, so the journal is still going on, right, for hundreds of years already. Okay, so you can see these are all the references. Okay, and all the data are available. Okay, so in fact, the data set that you saw me giving the lecture on is based on David G. Kleinbaum books from Epidemiologic Research Principle and Quantitative Method. Okay, the book is available. Okay, same like the Breslow and NDD test. You can Google it up and can download it. And the Robert E. Theron, 1985. This one is available also online. You can look it up. Okay, and you can enjoy yourself reading about all these things. If you understand the Greek words inside uh, the whole thing, feel free to share with me about the explanation. Okay, and with that, we're done. We're finished. Okay, so now time to change my screen. Right now I'm worried. The cats are very noisy down there. Okay, I'm not sure what's going on downstairs. Hopefully they're not making a mess down there. Boleh share slide. You want me to share the slide on the screen or slide dalam blog macam lain sikit. Sama lah. The only difference is the quadratic equation. Okay. The only difference is the quadratic equation. Nanti I share inside the Facebook group. Okay. 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 At least we know that Fatihah has already found the slides. Oh, QR code. Sekejap ya makcik. Okay. 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 Let's see whether I can share the QR code again. Okay. Sharing the QR code. Is it coming out? The QR code?
Tak ada, Prof.
Tak keluar?
Blank screen.
Ada
Blank.
Prof?
Huh?
Okay, dah keluar.
Okay.
Ada Prof.
Okay. Alright. So we are done. I think of all the lectures, this is your heaviest yet.
Yes, Prof.
Okay. Okay. Sumi dah masuk, Nabila dah masuk. Okay. So okay Ya.
Nak tanya apa beza yang test ni dengan MLR, Prof?
Bukan MLR, MLOG R.
Multiple logistik lupa.
The okay. You have to understand the MLOG R came in 1961. Okay, 1961. So when these people came up with the MLOG R, okay. Kita tengok tahun kita tengok tahun. Okay. Okay, let me show you the slide again. Nak tak nak benda ni kena tengok historical perspective. Okay, you have to understand who came first, who came next. Because basically new knowledge it is when enlightened people, clever people, they meet each other. Okay. For example, when did we get the Fisher's exact test? We get the Fisher's exact test because the statistician Fisher went to have tea, and they had a lady who is very stubborn, who insisted that she can detect the different tastes of all the tea. And from that one scenario, they came up with this Fisher's exact test. Yeah. So all these things happen usually because there is a triggering factor. Happen because there is a triggering factor, and all these triggering factor, they had an effect on each other. Okay. So I'm going to share the screen now. Why I'm sharing the screen? I don't feel like changing the one on my OBS studio. Okay. As mentioned just now, the MLOG R came out in 1961-62. If you look carefully in terms of history, MLOG R, although it came out in 1961-1962, it did not really catch on because it uses natural log. It uses natural log E. And without computers to calculate the log E, for each one of the analysis is tedious. Okay, if you look at the history, Cochran test and the Mantel Haenszel test came out in 1954 and 1959 before the MLOG R. That is why for the Cochran test and Mantel Haenszel test, they were popular all the way until the year 1980. After 1992, computer become much more popular. The first software for statistics, SPSS, came out in around 1996, but it only became popular in the year 1998-99. Okay, version 6. Okay, so by the way, I'm talking about SPSS version for the PC, not version for the mainframe. The version for mainframe, the 1960s already got. And they came up with all these statistical tests, MLOG R, so on and so forth, using SPSS. With computing power, it is easier to do the logistic regression. That's why the logistic regression now is very, very popular. You look at all these people, they are publishing all using a logistic regression. for the for this Mantel Haenszel, he was mostly taught on how to calculate manually to the earlier generation. So way back in 1999, whenever people seeing Prof. Rampal and they're having problem trying to calculate, trying to see whether the disease is caused by the risk factor or is it caused by the confounding factors, Prof. Rampal will always say, oh, we should do this Mantel Haenszel test. But at the time, I didn't know about Mantel Haenszel test. Okay, I did not know because it was not covered. It was not part of the curriculum. Okay, so only when Dr. Hidayah came, Dr. Nur Hidayah, she started to introduce mental Haenszel analysis to us. That's when we become much more pervasive in UKM. Okay, so with the advent of SPSS, it is easier to calculate both ways, either using Mantel Haenszel or using M-log-R. But right now, because of the convention, whenever you're trying to control for confounding factors and you have only a few, one or two, you use Mantel Haenszel. But nowadays, when you do a study, you have a lot of variables and you want to include all the variables. And they could be continuous data, they could be polytomous data, they could be dichotomous data. And you find it is easier to do at one go using SPSS. That is why M-log-R become much more popular compared to the Mantel Haenszel. So in short, in summary, Mantel Haenszel is good when you do all these things manually. They will say Mantel Haenszel is better because when you're trying to control for confounders, you're not taking a lot of variables, you're just taking one or two. And in fact, most of them are dichotomous. Okay? So Fatia, I hope that's clear. The difference between Mantel Haenszel and M-log-R.
Prof, satu lagi soalan.
Ya. Yeah.
Prof, tadi kan contohnya dekat mental hazard test tu kan Prof bahagikan age less than 55 and more than 55. What if kalau kita ada a few group of age? Is it possible untuk buat mental hazard test ni?
Tak. Dia dichotomous. Satu syarat yang utama dekat pangkal dia, it is dichotomous. Remember, you marry two, you die. Dichotomous. Okay.
Well, thank you.
Okay, so I hope that's clear. Okay. Fatia, kau mana AKU
IMR.
Oh, padan lah. Oh,
Tak pandai pun tapi.
Yelah, tapi soalan-soalan tu power kan.
Tak Prof.
Okay. Okay, so it is almost 10:30. I think you are tired. I'm giving you the outcome of 4 years, 5 years of what I learned over last 5 years in the last 2 hours. Okay, I know it's a lot, but remember, tak keluar exam. Tak keluar exam. Kalau keluar pun, epic in exam. But I just now, like you said just now, Prof Azma tak cover how to calculate manually kan. So you're okay lah. During my time, Hidayah showed how to calculate manually. So we have to do it manually. So in fact, I miss Hidayah. When I was attending class, it was not Hidayah teaching, it was someone else. So I only knows about this later on after I already finished my masters. Okay. So in fact, you all are lucky because we are trying to make sure that all the relevant pertinent knowledge is being passed on to you all so that you don't look lost when you become RA or a researcher at any of the research institute. Okay? Okay, I think I better stop here. because right now there's too much sharing. I forgot I'm also streaming to Facebook. I better switch off the Facebook. Okay, thank you very much. So I will stop the recording here now. Okay, kita tutup Okay, tak ada apa lagi kan? Okay, just enjoy yourself. Just say, remember to tell yourself, tak keluar exam, tak keluar exam. Jangan panic. Okay, alright. So we already stopped the recording. I'm going to leave you all here. Bye-bye. Alamak, tak boleh tutup.